Hi, and welcome to Geeks for Geeks. Today, we would be discussing yesterday's problem of the day, that is, unique path in a grid. So, without any further ado, let's get started. So, my thought about this problem was that this problem is a very standard problem in a particular topic. I won't reveal the topic because that would just destroy all the intuition based things. So, moving forward to this, I suppose that anyone who has a little bit of experience with DP should have solved this. Even if you don't have, consider solving this problem because this problem mm, provides a base to many other different difficult problems or problems with varying, like this idea with a twisted form. Okay, so I think we are ready, good to go. So I would just share my whole screen itself, entire screen, so that I don't create confusions. And it's done. Okay, hi Rishit, how are you? So this problem is a easy problem. So basically, you can visualize this problem in the form of game kind of thing. Okay, so you can visualize this problem like you are given a matrix. Like suppose a game of matrix is there. Now, suppose what happens is, suppose this is a 4 cross 3 matrix. Okay, so now some cells would be blocked. Okay, suppose you stand at this position. Okay, this you would stand at 1 and 1, row 1, column 1. You would stand in the left topmost and right bottommost. So you are starting from there and you want to reach here. Leftmost top, rightmost bottom. You want to go from this to this. And in the process of doing that, the conditions are that these kind of cells might be blocked. Okay, either of the cells can be blocked or something. Now, you want to know how many paths do exist from starting point to the ending point. See, this is one path. So I would just explain you what all paths we have. So do we have more path? Yes, let's make it more path. Like say, we can have this kind of path also. Let's do it with a different color. Yep. Let's say, okay, we can have this kind of path also. Then what we can have, let's remove this also, and let's say that we can have this kind of path also. And you can visit each cell exactly once. So basically in this problem you need to count the number of paths from this to this. Okay. So now see, basically suppose you have n number, so you can visualize this problem. Suppose you are standing in the middle of a forest and in front of you you have different paths. Okay. And suppose someone is asking you how many of these all paths lead you to the country roads. Okay, आप खड़े हो एक फॉरेस्ट के बीच में एंड यू वांट टू नो कितने पाथ आपको कंट्री रोड तक लेके जाएंगे. Okay, so the solution to this would be that I would take a walk on each of the path, and each of the path that lead me to the country roads, I would just count them and I would return them. So basically, the learning from this that I want you to understand is that travel each path. So, travel each path means that we need to try all possible combination. All possible combination. We need to try all possible combination. And we need to return the valid ones. So whenever we come across the conclusion that we need to try all possible combination, then it is nothing but what? Recursion. Okay. So in recursion, we have a thing known as base case. We have a thing known as recursive case. These are the only two cases we need and we are good to go. Let's talk about the base case. Base case is the smallest case that we can handle by ourselves. Smallest valid case. What is basically a base case? Base case is a smallest valid case. So smallest valid case would be that it is just one. Why? Because zero can't be there, n and m can never be zero, it starts from one. So let's take the smallest valid case, that source is equal to destination. Source is equal to destination. If source is equal to destination, suppose I am here and I want to reach here only. Suppose I'm already at Geeks for Geeks and I want to be at Geeks for Geeks only. So there is only one way, that I remain as it is. So I would just say that the answer to this is just one. That there is no other way I can reach Geeks for Geeks. Why? Because I'm already there. Okay. Let's talk about the recursive case. Suppose I'm standing at this position. So from this position, I can either move on the right hand side, I can either move down. This is what is said. Please see to this. See, right or down direction from every cell. So I can either move on the right hand side, either I can move on the left hand side. So if, see, there are two options to me. Suppose I moved to the right hand direction and here I have moved to the down direction. So from right, I can again move to right hand direction only and down direction only, right hand direction only, down direction only, right hand direction only and down direction only. And out of this, the maximum of these two, like, I have only two options. Either I can move right, either I can move down. So if I have two options, the maximum of it would be my answer. Okay. So from each point, we would go to right and we would go to down, and maximum of that would give me the answer. And what is basically moving right or down? Let's see that also. This is 0 0, this is 0 1, this is 1 0, this is 1 1. So if we move onto the right hand side, then it becomes j plus 1 and I remains the same. If you just observe, the columns increase but the row remains the same. If we go down, the row increases and columns remains the same. Okay. So we would just do maximum of row and column plus 1 and column plus 1 comma row. This is what we would do. Okay. And smallest valid case is already occurred. So let's start the coding part. So now I would say it would return me the number of path. So I would say int rect. Okay. Then I would need the size of n cross m because I want the smallest valid, I want the base case. Okay. So I would say int n comma m. Okay. And int, and then I want the vector also. Then I want the vector this as a itself. Now there might be a scenario that this is suppose the figure, and from this position I can move to down but I can't move to the right hand side. This is not allowed. So I need to check if I'm within the boundary or not. Like, I am going to take the next step, but I want to check if I'm within the boundary or not. Suppose my mother has told me that yes, Siddharth, you can go out and play, but you need to be inside the society. So whenever I would consider a playground to play, I would see if I'm within the society or not. In the same manner, whenever I would consider to take a step, I would first see that this step is within the boundary or not. So here I would say that I would just design within the boundary or not. So I would say boolean safe. Okay. And here I would take int x and int y. And here I would take in n cross m. Like n cross m is the dimension and xy is the new location I want to go. So if x is less than 0 or y is less than 0, why? Because index can never be negative. If x exceeds or equals to the value of n, then obviously this can't be true because the value can range from 0 till n minus 1. Okay. So in the same manner, if y is greater than equal to m, then I would say return the value 0. Else return the value 1 itself. Okay. Now I would say if n is equals to 1 and m is also equals to 1. Okay, if source is equals to destination, then we would return 1. Okay, okay. So we need n cross m. Okay, let's take the current position also. So int row, int column. So if we are, so if r is equals to n, r is equals to n, and column is equals to m, then return 1. Okay, simple enough. Like if source is equals to destination, this is source, this is destination. If source is equals to destination, we would return 1. Else, we would initialize the answer variable and we would initialize it with 0. And we would say answer is equals to answer plus rec of row remains the same and column increases. Like we are moving on the right hand side. Okay, and the size of the matrix remains the same, a also remains the same, and then we also need to move forward to the down part. If we move down, the row increases but the column remains the same. So rec of row plus 1 comma column comma n comma m comma a. Okay, at the end we would just return the value of answer. Now let us first check. Okay, so we would say if this path, we can visit this path or not. If it is safe, r comma c plus 1 comma n comma m. Suppose the position we are trying to go, if it is within the boundary first, if it is within the boundary and the array that is given, 2D array that is given, we are allowed to go in that point, and a of r minus 1 comma column minus 1, or let's make it 0 indexed only. Okay, let's make it 0. Let's make it 0 indexed only. Like we would start from 0. So we would say that n and m are n indexed 1. So if the last value of an array, suppose there are 4 elements, 1, 2, 3, 4. So the index of the last value would be 3, but the size is 4. So in the same manner, if r and n minus m minus 1 is equals to the last value, so if you see the indexing, it would just refer to the bottommost right value and we would return 1. Now let us just see if this is getting correct or not. And it is correct. Let me see. And 0 implies that the cell is not allowed. Okay. Cell is not allowed. 0 means not allowed. Okay. R and C plus 1. This time this would be R plus 1 comma C. Okay. If we can visit, like if it is safe, so there are two conditions to go left and right. First we need to check if we are within the boundary or not. If we are within the boundary, then we need to check that if that road is blocked or not. Within the boundary is checked by this and that road is blocked by check is this. Okay, so if both the conditions are true, we would return true. Now we would just see return rec of 0 comma 0 and n and m would remain the same, and then we would just pass the grade itself. Now let us see if we are getting a correct output in the sample test case or not. We are getting correct output, but when we would submit this, we would see that the time complexity of this approach is not sufficient enough to pass. See, okay, so am I clear till this point or not? It should be some instead of, because we want the count of unique path. Rec of r comma 0 is not a valid path as well. Yes, absolutely, it's done. Anything more you have? Just tell me quickly. Anything more? Like, is the am I correct till this point or not? So we need the count of unique path. Basically, you don't need the maximum of it. So I told you maximum, but that is like I missed that part. Let me just see. I told you maximum. Okay, I told you maximum. No, it would be like all the path that let me reach the destination. I'm clear till this point. Now let us move forward and let us. So now we need to solve this thing. How to solve this thing? Okay. So basically, if you just observe, the time complexity is this approach is 2 to the power n. Why? Because the number of nodes at this point in the worst scenario is 2 to the power 0, 2 to the power 0. Okay. This one would be 2 to the power 0. This one would be 2 to the power 0. This one would be 2 to the power 1. This one would be 2 to the power 2. This one would be 2 to the power 3. At each subsequent step, we would just move to 2 to the power. That is why the time complexity of this approach is 2 to the power n. This is why it is. Okay. So basically, we need to memorize the solution. Why? Because optimizing recursion can be done by a simple memorization technique. So now we need to save the value. To save the values, we can see that only the values of R and C are changing. Okay. If R and C are changing, if we want to save the values, this can be a subsequent way. So we would declare R and the value of R and C can range from 0 till n minus 1 and C can range from 0 till m minus 1. So we would say vector of vector int, okay, vector of vector int dp of size n plus 1, n plus 1, and then vector of int of m plus 1 comma minus 1. We would initialize that none of the answer is given up till now. So basically we are initializing it with n plus 1, because whatever be the logic, even if our logic is 1 based, even if our logic is 0 based, it would work in both the scenarios, and one more space won't affect the time complexity. Okay, so now we would say that we need to pass it. So here we would pass the dp array with pass by reference, and we would say dp. Now, whenever before computation, we would see if the answer is already stored or not. So we would say if dp of r and c is not equal to minus 1. That means if it already has a value, then return that value dp of r and c. Else, before returning, we would save the value dp of r and c is equals to the value of answer. Now there is one more thing. The value can be very large. So we need to do it modulo 10 to the power 9. So now let us quickly revise our concepts on modular arithmetic too. So modulo arithmetic tells us that if it is a plus b mod modulo m, modulo arithmetic tells us that if we have a plus b modulo m, then it would be a modulo m plus b modulo m and then whole modulo m itself. Okay. So we need to do this. So how to do this? We would say if we want to have a modulo over this thing, this is A, this is B, A plus B, and we want whole modulo. So answer modulo mod, this modulo mod, and the whole thing modulo mod itself. We would wrap up the whole thing again. Okay, and here we would say const int mod is equals to 1e9 plus 7 itself. Okay, and here we would do the same thing. So we would just copy the same thing because writing this is more tedious. So I would just copy this, and this would be r plus 1. Okay, simple enough. So we would do modulo at each step. At the end, we would just return the value, and that would be sufficient enough. Now let me just compile and run again. In member function. Okay, we need to add the DP array also. Okay, here also we need to pass. Answer is equals to -1. If dp of rnc is not equal to -1, return. So are we passing by reference? Yes. Okay. Here answer is equals to answer plus this. So where I'm making the mistake. So okay, let me just see it myself. dp of r and c is equals to answer. Okay, we would initialize m+1 grid and dp. I think we are doing everything fine. If it is safe and it is true, and dp of r+1, and this is. So are we given a character or something? Let me just see. Your output -1. One on line number 20 there is a typo. If dp of not equal to -1. Okay. Okay, fair enough. So your code output and its correct output is this. Okay. 10 to the power 9 plus 7. Are we still not done with it? Mm-mm-mm-mm-mm. This is 10 to the power 9 plus 7 only. We are correct up till this point. Okay, if y is greater than m, return 1. Yeah, correct up till this point. If I m plus 1 is equals to. Okay, let me just type it again. I think so. Any more line number two instead of. No, it is correct. dp of rnc is equals to answer only. We are returning the correct thing. Okay, let me just write it again. I don't know what is happening. at this point because it would be very hard to detect. In constant mode is equals to 1 e9 plus 7. It is done, and then int rec int r comma c, and this would be int n comma int m, and this would be vector of int and a, and then vector of int passed by reference the dp array, and here only we would write the safe thing. So if I is greater than equal, if row is greater than equal to n, or column is greater than equal to m, or a of row or column is equals to 0, or this all thing is sufficient, and then we would return 0 from this point. Here we would say if row is equals to n minus 1 and column is equals to m minus 1, then we would return 1 from here. If dp of row in dp of row comma column is not equal to minus 1, we would return dp of row comma we would return dp of row comma column, and then we would say int down is equals to rec of row plus 1 comma column, row plus 1 comma column, and then we have the a, and then we have the dp array, and then we have the down part, and then we have the right part. And here we would say rec of row comma column plus 1, and then a comma dp itself. And then what we can do is we would say that return dp of row comma column is equals to b plus r modulo mod itself. We would do this thing and this would be done. Here we would initialize a vector of int, and then we would say dp of size n plus 1, and then we would say vector of int, and then we would say m plus 1 comma minus 1, and here we would say return rec of 0 comma 0 comma n comma m, and then grid comma dp. This is correct. Now let me just see. Yes, everything looks fine. This solution is a little bit more concise. Mm, 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 mm. RC and dp. Okay, rc comma n comma m. Here we just need to have rc n comma m comma a comma dp. Yes, this looks fine. Okay, right down, because row and column, right is row as well as the right part, so both are correct. We are done. So basically, I never rewrite my solution. I try to debug it. But then I remember that yes, everything can be done concisely. Like, yes, doing right plus down whole modulo mod won't give you the correct answer every time. Sometimes it might be the scenario you are getting wrong answer. This is not a good practice. But if you are doing this in an online interview, like online judge, you would be able to surpass it. So if you want to write in a concise way, this is the way. But if you want to clear your understanding, and if you're writing this in an interview, it is advisable that you do functional programming. Okay, so that's it from my side. I would still share this. I would still just ask you that at what points you are not able to understand. Just tell me the line number. Unique path in a grid, and there. Just tell me the line number. So we can check for the first and the last and the previous and then further on up to the yes, absolutely. Okay, so I don't think I have any further issues that is left. So so if you're watching this stream in the recorded version, feel free to like and comment on this video so that the reach of this video could be increased. That's it for today. Thank you and have a nice day. Good night, everyone.